Hello dear students, welcome to Corner classes. In this session we are going to solve differential equation of first order and first degree using variables separable. Okay, as you see in the board it is written as variables separable. Okay, what is meant by that, dear students? So if you recall that in the previous session we briefly discussed about the differential equations with variable separable. What is that? Suppose we have a differential equation dy dx is equal to fxy. Okay, it is a function of x and y. Okay, two variables. Now if we can express this function as a product of two functions, okay, such that this thing we can write is that this is equal to gx into hy. Okay, not all functions can be expressed as a product of two functions, one function on x and another function on y. Then we cannot approach this methodology. But if we can, then what we can do, dear students? After that, what we are going to get, so this implies dy by hy is equal to gx dx, subject to the condition that hy is not equal to 0. Okay. If hy is not equal to 0, then only we can write this thing. After that, what? It is pretty straightforward. We will perform integration of both the sides, because this is a function of y, 1 by hy dy and integration gx dx. So if we integrate 1 by hy with respect to y, what we are going to get? Suppose we are going to get a function called capital hy. That should be equal to, once we integrate the function gx with respect to x, suppose we get gx plus c, where c is the integrating constant. So this is the solution to the given differential equation. This is the differential equation and it is the solution. Moreover, it is a general solution. Why? Because that c is an arbitrary constant. You can vary c and you will get different solution. And all those different solutions for specific values of c, it will be particular solution. Okay. So this is the theory. Now let's solve few questions. Okay, so that it will be much clearer. Okay, you also do along with me. I am going to write the question one by one from my notebook. Okay. The first question what I am writing here, okay, this is not working. The first question, dear students, here it is. Find the general solution of the differential equation. Find the general solution of the differential equation. And what is the differential equation? Dy dx is equal to x plus 1 divided by 2 minus y, and it is given that y is not equal to 2. Obviously, then only this right hand side of this differential equation makes sense. Otherwise, it will be something by 0 which is undefined. Now let's see how to solve this particular question. Okay. So what is this dy dx equal to? So we see here dy dx is equal to x plus 1 divided by 2 minus y. Now dear students, if you see this function x plus 1 by 2 minus y can be expressed as a product of two functions. What are the two functions? The first function is on x, that is x plus 1, and the second function is 1 by 2 minus y. 1 by 2 minus y. So now as we are able to express this function, this given function, as a product of two functions, so what we can do now? So this implies 2 minus y dy is equal to x plus 1 dx. Correct? Same procedure, that dy by hy is equal to gx dx. Same thing, 2 minus y dy is equal to x plus 1 dx. After that, we will perform integration to both the sides. Now it is pretty straightforward. Integration 2 minus y dy. This implies 2y minus y square by 2. That is equal to integration x plus 1 dx. That is equal to x square by 2 plus x. And we get one integrating constant called c1. Correct? Now what we will do, we will rearrange. So if we rearrange, we will get something like this. We will multiply both sides of this equation by 2. What we are going to get then? X square plus y square plus 2x minus 4y plus 2 into c1. So let's take it as c is equal to 0. We can write where c is equal to 2 into c1. Correct? So now dear students, this is the general solution. X square plus y square plus 2x minus 4y plus c equal to 0 is a general solution of the given differential equation dy dx is equal to x plus 1 by 2 minus y. Why general solution? Because it is having an arbitrary constant c. If we apply a specific value of c, then it will become a particular solution. In one of our previous session, when I was explaining that how to form a differential equation from a particular solution, I used a specific value of c and we obtained this is a differential equation. You can refer to that session. Okay. Now let's proceed to the next question. Okay. These are very simple questions, but understanding this is very important. Okay. Let's proceed to the second one. Okay, dear students, the next question I'm going to write it on from my notebook. Okay, find the general solution of the differential equation. Find the general solution of the differential equation dE, I am writing in short, dy dx is equal to 1 plus y square divided by 1 plus x square. Okay, so how to proceed, dear students? So dy dx is equal to 1 plus y square by 1 plus x square. That function we can express as a product of two functions. What is the first function of x? That is 1 by 1 plus x square into the other function which is on y, that is 1 plus y square. Variable separable. So now what we can do? This implies in dy divided by y square plus 1 is equal to dx by x square plus 1. Done. After that, it's pretty simple. We will integrate both sides. And we know that integration dy by y square plus 1 is tan inverse of y. Okay, is equal to integration dx by x square plus 1 is tan inverse of x plus 1 integrating constant c. So you can write where c is integrating constant. Okay, so this is a solution to the given differential equation. So tan inverse y is equal to tan inverse x plus c is the solution to the given differential equation. dy dx is equal to 1 plus y square by 1 plus x square. Okay, the next question what we are going to do, dear students, is that to find the particular solution. So let's see. Okay, the question number 3. The question here is, find the particular solution of the differential equation. Find the particular solution of the differential equation dy dx is equal to minus 4x y square, given that y equal to 1 when x equal to 0. Y equal to 1 when x equal to 0. Okay, dear students, so let's see how to approach. So dy dx is equal to minus 4xy square. So what we can write, dear students? Dy dx is equal to minus 4x into y square. We are able to express minus 4xy square as a product of two functions, one on x, that is minus 4x, and another on y, that is y square. After that, quite straightforward. This implies y to the power minus 2 dy is equal to minus 4x dx. After that integration of both the sides, minus 4 is constant, so we took it outside of the integration. So y to the power integration y to the power minus 2 dy is what, dear students? Y to the power minus 1 by minus 1, that means minus 1 by y. Minus 1 by y is equal to minus 4 into x square by 2 plus c, where c is integrating constant, right? Where c is integrating constant. Correct? Now let's simplify a little bit. So from here what we get, dear students? So we get minus 1 by y is equal to minus 2x square plus c, or we can write from here that 1 by y is equal to 2x square minus c. This implies y is equal to 1 by 2x square minus c. Dear students, this is the general solution because it is having the arbitrary constant c. Now, according to the question, it is given that y equal to 1 when x equal to 0. This initial condition will help us to find the value of this integrating constant c as a real number, and then we will apply it here and we will get the particular solution. So let me do it here. So if I do it here, according to the given question, when x equal to 0, y equal to 1, that means we can write x equal to 0 and y equal to 1 in this general solution. That means it will give us 1 equal to 1 by 2 into 0 square, that is 0 minus c. 1 by 2 into 0 square minus c. So from here, what we get, dear students, we get the value of c as minus 1. The value of c we get as minus 1. Now that value of c as minus 1 we will apply back here. Okay? And what we are going to get? We are going to get the particular solution as, we can write it here, that y is equal to 1 by 2x square plus 1. This is the particular solution. Okay? I hope you got a very clear idea. Now, dear students, in the next session, we are going to solve 3 more questions, on differential equations using variables separable, and those will be, questions given in a problem statement. From that problem statement, we need to give a geometrical interpretation followed by the solution. Now, if a question is something like that the function is not, expressed as a product of 2 functions, one is x and another one is y, then what we should do? We are not able to solve using the variable separable method. For that, there are different methods that we learn in some other sessions. With this note, let me conclude the session here. Your task is to log in to the online test platform at konarclasses.com and appear for DPP, that is daily practice problem, followed by UT, that is unit test, followed by MDT, that is module test, followed by mock test, and your learning will be fantastic. Bye bye.